day, Bayaw. Welcome to our YouTube channel, Bayaw Tutorial. In this video, we are going to solve a problem from thermodynamics and heat transfer that involves the ideal gas and the corresponding states and incompressible models. So here is our problem. Heat is applied to a piston cylinder device containing water in a predetermined state. The tank volume, final temperature and pressure, and internal energy change of water must all be determined. So in this problem, we have a diagram. So the piston cylinder device contains water and it has a mass of 1.4 kilogram and 200 degrees Celsius as its temperature. So before we are going to solve what is asked in this problem, we need to identify first the given values. So we have mass, which is equals to 1.4 kilogram, the temperature, which is also equals to 200 degrees Celsius. So we need to find the volume, the temperature, the pressure, and the change in internal energy. So the initial volume of the cylinder is determined from the given mass and the specific volume of the saturated liquid water at the given temperature. So we have given temperature, which is equals to 200 degrees Celsius. So we need to find the value of saturated liquid water at 200 degrees Celsius. So we obtain from the table A-4 volume is equals to mass times the saturated liquid water. So by plugging in the values, the mass, which is equals to 1.4 kilogram, and the value of the saturated liquid water, which is equals to 0.001157 cubic meter per kilogram. And by multiplying these two given values, we can get the value of 0.001619 cubic meter. Now we have the value for our volume at state 1. So we can now solve for the final volume. And do not forget to cancel the same units. So now we have the final volume, which is V sub 2 is equals to 4 times V sub 1. So we have the value for V sub 1, which is equals to 0.001619 cubic meter. And by multiplying these two given values, we can get the value of V2, which is equals to 0.006472 cubic meter. So next, the final specific volume is determined from which the final internal energy, pressure, and temperature can be obtained. So the specific volume at state 2 equals to volume at state 2 divided by mass. So we have the value for our volume at state 2, which is equals to 0.00644729 cubic meter divided by 1.4 kilogram is equals to 0.004628 cubic meter per kilogram. So now we take this value, and look for which temperature it represents the specific volume at the vapor state using data at the table A-4 and interpolation. So we have T sub 2 is equals to T sub 1 plus T sub 2 minus T sub 1 all over the saturated liquid water at 373.95 degrees Celsius minus saturated vapor at 370 degrees Celsius times V2 minus V sub G at 370 degrees Celsius. As you can see, these values, we get this at the table A-4 and by using the interpolation. So by plugging in the given values, we have 370 degrees Celsius plus 373.95 minus 370 degrees Celsius divided by 0.003106 minus 0.004953 meter cube or cubic meter per kilogram times 0.00462H, which is the value of our specific volume at state 2, minus the 0.004953 cubic meter per kilogram. And by simplifying this equation, we can get the value of 370.7 degrees Celsius. Now we have the value for P2. Next is the final pressure and internal energy are determined in the same way. So we need to solve for the final pressure and internal energy. So this is our equation for our final pressure. So by plugging in the given values, we have 21,044 kilopascal plus the difference of 22,064 minus 21,044 degrees Celsius divided by 0.003106 minus 0.004953 cubic meter per kilogram multiplied by 0.004628 minus 0.004953 cubic meter per kilogram. And don't forget to cancel the same units. And again, by simplifying this equation, we can get the value for our final pressure, which is equals to 21,223.5 kilopascal. So before we need to solve for the change at change in our internal energy, first we need to solve for the specific internal energy, and we're going to use this equation. The specific internal energy at saturated vapor at 370 degrees Celsius plus specific internal energy of saturated liquid at 373.95 degrees Celsius minus the specific internal energy saturated vapor at 370 degrees Celsius divided by the specific volume of saturated liquid at 373.95 minus the specific volume of saturated vapor at 370 degrees Celsius multiplied by the specific volume at state 2 minus the saturated vapor at 370 degrees Celsius. And plug in the given values, we have 2,230.1 kilojoules per kilogram, which is the value of this, and the difference of 216.7 minus 2,230.1 kilojoules per kilogram divided by 0.003106 minus 0.004953 cubic meter per kilogram multiplied by 0.004628 minus 0.004953 cubic meter per kilogram. And by simplifying this equation, we can get the value of our specific internal energy at state 2, which is equals to 2,192.4 kilojoules per kilogram. Now, we can solve for the change in the internal energy. So, the internal energy change is determined from the calculated final internal change and the initial one taken from table A-4. So, we have the equation of the change of internal energy is equals to mass times mu sub 2, or the specific internal energy at state 2, minus the specific energy saturated liquid at 20 degrees Celsius. And we have 1 point per kilogram as the value of our mass. The value of our U sub 2 is equals to 2,192.4 kilojoules per kilogram minus 850.46 kilojoules per kilogram. And by simplifying this, we can now have the value for change, or the internal energy change, which is equals to 1,878.7 kilojoules. So now this is the result to our problem. The tank volume, which is equals to 0.0064792 cubic meter, and the value for our final temperature, which is equals to 370.7 degrees Celsius. The value for our final pressure, which is equals to 21,223.5 kilopascal. And last is the value of our internal energy change of water, which is equals to 1,878.7 kilograms. So this is the answer for this problem.